My name is Roksana Sadeghi, and I am a PhD student in biomedical engineering working at the Ultra Low Vision Lab at Johns Hopkins University in Baltimore. Based on a study in 2020, an estimated 43.3 million individuals had blindness worldwide. Several diseases cause severe visual impairment. Age-related macular degeneration, glaucoma, and diabetic retinopathy are among the most causes of blindness. Many forms of blindness result from neural damage that is irreversible. Currently, there is no treatment or cure for many causes of blindness. A survey conducted in 2016 showed that normal individuals have the greatest fear about vision loss. Human uses vision in almost every activity. The precision, accuracy, and movement synchronization in nearly all activities come from the error we receive from visual feedback. People with severe visual impairment may have trouble with balance, orientation, and mobility. Therefore, with blindness, simple daily life activities become challenging. People with blindness may lose the ability to be independent. Severe visual impairment affects a person's economy. In the United States, people with severe visual impairment have long suffered high rates of unemployment. Only 37% of individuals with visual impairments are employed. Depression and other mental health issues are reported commonly among these people. The chance of physical falling or have other physical health issues are higher in blind people than normally sighted individuals. Thus, blindness reduces the person's quality of life significantly. Here in Dr. Danelli's lab at Wilmer Eye Institute, we are trying to improve the quality of life of individuals with blindness using electrical stimulation. Vision restoration using electrical stimulation has a long history. It all started a century before Thomas Edison invented the early version of the electric light bulb. Around 1755, Leroy reported patients seeing flashes of light while receiving electric shocks as a treatment for blindness. Of course, the treatment didn't work, but demonstrated that electrical stimulation can create visual perception. Since then, so many groups worldwide have started working together to build a device that can provide visual perception for blind individuals. All visual prostheses have a common idea. The user is wearing a pair of glasses that has a camera. The camera captures the image in real time that would normally be projected onto the retina. The camera sends the image frames to the mini computer that processes the image and assigns each electrode the correct pulse parameters. These pulse commands will be sent to the implant wirelessly using a telemetry coil. The electrical signal will then result in visual perception, and the user can see flashes of light. Unlike normal vision, people with current visual implants don't see colors. Due to the neural damage caused by the disease and due to the current limited electrodes, the visual scene becomes blobby with very limited details. They only see more visual scenes as crude shapes and moving shadows. Even though this is a simple perception, it is helpful for orientation to see the ceiling lights, a doorway, or window, and they can tell if there is any movement in front of them. Our team, in collaboration with the Illinois Institute of Technology, has developed an intracortical implant called ICVP, where the penetrating electrodes will be placed on the primary visual cortex located at the backside of the brain. In many blindness diseases, the cortex stays normal, and by stimulating the visual cortex, we will bypass the retina and optic nerve. Therefore, many people with blindness can benefit from this device. The visual cortex has a large area and makes it possible to implant hundreds of electrodes. By using penetrating electrodes, more localized stimulation can be provided, yielding more detailed perception. ICVP is a fairly new device in the clinical testing phase, approved by Food and Drug Administration and approved by Institution Review Board for Human Testing in the United States. In my PhD thesis project, I am developing methods to create a meaningful visual perception with ICVP. To map the camera image frames to the implanted electrodes, we need to know what pulse parameters create visual perception. And Can visual percepts have different brightness? And also, what is the location of the visual percepts? We are currently looking for enthusiastic volunteers, hoping to have our first implantation in the next few months.